Yeah. So recording is on. This is the SIG subgroup package specialization as part of SIG automation, where we are diving into the package specialization topic. So it's the 15th of March, 8 a.m. PST. So let me share my screen. So do you see my screen? So first, so what we are trying to do, just maybe in general, we try to follow the same principles as the main automation meeting. So I created let's say a document like the specialization subgroup. So this document is freely for everyone to access. So if you have topics that you are proposing, you can basically submit them inside of the document, such that if there is specific topics that someone is interested in or want to go through for the next meeting, then we will use this to actually help people do that. Of course, the focus which we have is on our release 1, right? So the goal is of the subgroup is to focus on the release 1 deliverables, and the target is that by the end of May, we should have a good basis in terms of code to be able to as part of the deliverables that we have, right? Now, before we start into the details, I keep saying the same thing. If there is a volunteer that potentially will lead the subgroup going forward, please let me know, and then we can discuss. Because I'm of the opinion that if we find more people who can lead things, we will grow Nephew at the end of the day. So I'm helping to guide or help that person to get there if needed, or if people already believe that they are in that role, then we can maybe do something earlier. But so I'm willing to support and help guide someone if interested to step up and get into this position. In terms of timings, as we discussed yesterday, I'm not sure whether everyone was on the call yesterday, but yeah, given that we have a pretty good mix of people in India, I was proposing to do the meetings now so Monday, Wednesday, and Thursday. So my idea is to actually initially do the pace rather quick and then maybe slow down if we have a good basis of understanding what we need to deliver, and we kind of can have a basis for divide and conquer. Now the Monday meeting is going to be, so there is overlap. So this will be every other week probably, right? Because this overlaps, I think, with SIG network SIG 1 with the network architecture at the moment. But I believe Friday is always bad. And the Tuesday slot is going to be taken by Tal, I believe. So I don't know if is there people, is this okay or not okay, or any objections? If not, I will put this into the calendar invite so that it's then known in all the calendars and stuff like that, and ensure that everybody knows if there is no objection, right? Okay, so the agenda that we set for today is, so yesterday we went through more of a controller-based example. So today the goal is to walk us through a function example. And so we have so the NAD injection. I think we built 2 functions for during the POC. So we can take both of them if you want. You can see the difference. But I was proposing to use this NAD inject function. And yeah, so basically the code is a bit different. So how this basically works is, so when we build a package, I support build the package. So in kept, so the kept packages, so the kept file has what they call a mutator. So you can have validating functions and mutating functions. By the way, for people interested, I also put a link into it so we can also go through this example. So there is a kept development. So there is a book here that explains this concept. And one of the things that I was planning to do today, to go through how you develop. So there is like an SDK or a developing environment. And I basically followed that when I built the project, to actually see how you develop those functions, right? Now, I think it might be interesting to start with going through such a function specification. Where was that? I thought I saw it yesterday. If you look to a function, so the way a function, or the way Porsche operates, and John probably will step in, is basically all the resources that are in a package, you basically get access to, in essence. So in other words, when you are presented, or a function when it runs, so all the KRM resources that are in such a package, you get access to, and it's presented in a resource list. I think that's the way it is represented. So let me go through the transformer file. So you see here that, so this resource list, so this function contains actually a list of all the items that you see here, which are actually the individual files, if you will, or the individual KRM resources that are within that package. Okay. Besides,
if I can jump in. Sorry, Wim, I'm driving, so it's hard for me to like raise hands and stuff. But I'll just say, yeah, the couple of just kind of notes, right? So the resource list is just a flat list of resources, regardless of like, say, the directory hierarchy. The directories get put into like an annotation, and you can see what directory they belong in and things like that. But just to kind of give people an image, this is just like a function is just a very simple pipeline. You get a list, which is basically an array of resources, and you output an array of resources, and that's it. Now, the thing is, those resources are not typed. They're just like unstructured cube or YAML resources. You generally want to keep them that way. You could load them into Kubernetes objects, save them out, and that's fine. But like if you keep them in the unstructured, things like comments, for example, in the YAML files will be preserved, whereas they're not preserved if you convert it to cube object, a Kubernetes object, and then write it out. So just sort of an FYI, just think of it as it's like stream editing, you know, in Unix. It's like you get an array of objects, you manipulate that array of objects, and you output an array of objects. That's it.
Yeah. And it's basically you step through them as a JSON type of object. So you will see in the code how you get access to that data. So you can basically, if you know the structure, there's ways to step through it and get access to specific elements or attributes of that data. So I basically, so this is a part of so this is actually good reading material for people. So what we talked about at the moment is this input item. So it's a flat list of these resources. One, I think, powerful element of this function, because, okay, I believe one of the key objectives that we have in our team is to make these functions as generic as possible, okay? So one way to do, of course, you can write a generic function code. There is another element that we can use to do that, which is the function config. So a function config is basically also a KRM object, which you could, so you can basically specify specific configuration so that you give as input to this function. In the code at the moment, we did not use that, but my idea so at the moment we have SMF, UPF, and AMF, for example. What you see sometimes in these CRDs or the CRs that represent them is some of these paths can be a bit different. So one of the things that what you could do is in the function config, specify AMF paths are these, SMF paths are these, UPF paths are these. And as a result, use it as an input in your function to make that code generic and use it as a configuration option to make that code generic, and then do it based on the context in which you execute, right? So that's an important element. We did not use that in the example that I'm going to show. We are not using that, but we have to keep in the back of our mind that that's a tool or a capability that we can leverage, right? How do you get access to that function config? This is part of what you add into the kept file. So when you create a mutating function, you have the ability to add such a context into it. Okay. So that's a little bit the background. So this basically that book here that I'm referencing. So there's individual pages. It's not so long to read. Also, I believe tomorrow, if I'm not mistaken, which is a bit bad for Indian time, I think it's 11 PST. I think Tal is going to do a workshop on kept and ports. I'm not sure into what detail he is going, but potentially that's also potentially can be used as a reference. So we will, I probably will record that session so we can have access to it if you cannot be in person. But these are all things that probably are useful to go through in case you're interested into the depth of what's going on here. Okay. So what I did so these functions, by the way, we can write them in any, so they are basically agnostic of, so they are language agnostic because they are actually packaged as a container by itself, right? So so you can execute that function. So and in an independent stack. And so basically those functions, they use standard in, standard out, and standard error. So in other words, the resource list, so the flat list that John was talking about, is represented to that function as standard in. And the output that you generate is going to represent it as standard out, right? And if there is no error, okay, then you don't have standard error, but basically that's how they operate. So in other words, what you see here is that there is different development environments on how you can write them. At the moment, I used Go, but Starlark is kind of a subset of Python. So it's a Python-alike thing, and you also have them in TypeScript right now. So these are the SDKs that have been developed to leverage them. I propose for our project at the moment, unless someone has a different view, is to use Go, because that's how we write most of our code. But I would leverage Go, the Go SDK to do so for the time being, because that's how we write most of our code into. Okay. So if we go, so I'll go through the code maybe first, and then we can basically see what's going on. Yes, is there a question? Yeah, I don't see the chat, by the way, so it's very hard. Okay, an overview of the folder structure. Okay, the folder structure of the code, Ganesh, that we have here, you mean, of the code itself?
Yes, Wim. I actually had a very small, I mean, like very high level look on the code. Like you can just explain what is this data folder, what does it ask to contain, what is the transformer folder? Just this, like the one that you're showing on the
good point.
Yes.
Yeah. So of course in Go, everything starts with main.go, right? So this is a very lightweight, actually, it just calls the transformer. So the way I wrote them is, okay, there is a main.go file, which I put into the main folder. Then we have data. Okay, we could also use another name, but this contains my TR. So if you look to that folder, it's actually a set of YAML files that I typically use to test the function. And you will see that in a bit, so I'll demo that. So in order to test your code or your function, you can actually, and I think it's in the README here. So if you do kept function source data, so what it does, it basically, so it basically emulates what you would have when you run it into port. So you basically represents all the resources that are in that folder. and it's presented as standard into this go run main.go file. So it basically execute that function. And if you run that, you actually can see how your code behaves on that data set. So I use it when I develop a function. So what I do is I always have a data set that I believe is representative, and it can be more than one, by the way, representative for that particular environment that you're developing. And then what I do is, while developing, I actually use this command to I test the code and see what the result is, to see whether my code operates or does the right thing. So that's what the data folder is. And then, so the first stage is basically developing it locally with go run main.go. The next stage, what I'm doing is I am using the kept function eval capability with the mutator, and then I use that data folder as well. So it basically also gives away, but it executes. So I basically built this file as in a Docker image. So this is actually way more representative in what will happen when you execute in ports. So first, when I develop, I always develop directly in this way. And the second thing that I do then is I build a Docker image from it. So the make file that you see here will do that. So, and I think the structure in the make file is is typically a Go based structure. And we use Docker build and Docker push to execute it. And the rest is go fund, go vet, and go test. So you can actually execute those type of things. So it's a very simple make file that does that. So if you do make Docker build and make all, it will actually push the images to a set of registry. We probably have to align this with how we set up the release structure, but this is a very simple make file that helps in developing and building the capabilities. Okay. So when I develop personally, and that's how I do it, and maybe other people have different views. I start like this, so because you can all do everything local. There's a bit of background noise. Is it you? Yeah. Okay. Sahir, I muted you. Sorry about that. Oh, no, it was not you. Okay.
Sorry. Okay. Thank you.
Yeah. So then, the next step, what I do is I basically I make a Docker image and then I execute in Docker image. Normally, there is no difference here, but it's just to test it. And then I go into the Porch thing, because actually what you do in Porch, in the kept file, you basically reference this Docker image that you then execute in the system. Okay. So what I always do is, I have a main.go file, then I have a transformer. So this is actually the thing that actually does the code. And then I create it, and this probably should not belong here, but should become a library eventually, on which most of our functions, let's say, tap upon or build upon. So what you see here is I have, let's say, libraries. So so in this thing, I have to manipulate and get access to certain resources from the IP allocation, so from the IPAM. So what I'm doing here in this library is, you see here, so this is kind of how you access JSON structs, right? So as John was saying, it's a flat list, and you have a YAML representation of things. And by the way, there is various ways on how we can access this. And I have explored various flavors of it. I don't have a real opinion, but maybe it's good. Maybe we can consult the CAP team to see what is the best approach of doing this. But so basically what you see here is when I need to have, for example, the gateway IP address, which is in this field. So I basically call get gateway based on status.gateway, and then I get the value that is, so the gateway that was allocated in the IP address was actually presented here, and I return it as a string. So, but you can go to slices, you have maps, you can access all the kinds of data objects. I believe if you go through this NAD, I'm not sure here. Yeah, I basically built a template. So you see that I've been exploring with various ways to, so because there's various ways that you can actually build these templates. So in this case, I had to create an NAD from scratch because that did not exist. So I created a template here that I render based on some input that I give it. So again, here, it would be good to have different opinions. So this is an approach that I took for this resource because I had to build it from scratch. You can also use regular JSON structs if you want as well. So I've also done that. And then I think the infra.
Yeah, if I can just jump in.
Yeah.
So there's a standard library KYAML that's part of Kubernetes, CI stuff, and then I know the KEP team built like a KEP function SDK or something. I wasn't able to see any advantage to that. I found it a little confusing. I'm not sure that it's really been like the KYAML library is kind of weird too. Like it, so. You know,
Yeah.
I agree with Wim. I don't have a strong opinion. I haven't yet decided which I find cleanest or easiest, but you know, we should, I guess, experiment with them and see if there's a better way we can do it. But I haven't been all that happy with the specific SDKs for manipulating these functions. I find them all both a bit awkward, or there's at least two. So anyway, just for whatever that's worth.
Yeah. No, true. It's the same. I have the similar view as John. So I've been exploring various ways, but I haven't found the silver bullet myself. So as you see, some of these codes use approach A, others use other approaches. So yeah, so I've been trying to explore and try to get an opinion, but you see that there are, yeah, there's no silver bullet, or I didn't find the silver bullet so far, and nor did John so far. So we seem to be on the same page. But what I put in package, in my view, they don't belong in this library, if I'm honest. They should belong. So I don't know whether we are on that, John. So the idea was to put our CRDs into a separate folder somehow. In my view, these are all libraries that go with them, right? Because you see that they manipulate or they give access to certain elements depending on the context that you use them through the CRD specification, right? So in my view, they should belong all into that CRD library. So there will be a regular Go struct, but there probably will be also YAML or YAML based ways to access that data, but in line with the CRD specification. So as such, I would like, or at least that's my view, to build a library where we can tap upon and then leverage those packages into our function. So the packages for me is basically just a set of capabilities or elements or methods on how I access the data that represents a CR. That's what they do.
Yeah, and I think it makes sense. That makes sense to me too. And I think it makes sense to like have a convention of like, okay, with this API, right, with this Go struct that represents a particular CR, you know, it lives in API v1 alpha 1 or whatever, but then maybe we have a similar convention of where which package these KYAML manipulators or whatever you want to call them are, where they live that are associated with that. And that would make sense to me that they live in that API repo as well.
Yeah. So that's kind of a little bit the surrounding. So in other words, they are ice, but the real meat is in this space. So I started, so what you see is if you go to the kept file, the kept here, there's a function catalog. So this is a set of functions that are maintained by the kept team that are very generic functions that can be used in various ways and flavors, right? And I've been using or going through some of these examples and then see what to do. And what I my convention so far was if I have to transform or create an object or something, I always create it as a transformer, in a transformer element, but this could also be a package. But so at the moment, that's what I did. And in that transformer, everything basically happens. Okay. So what you do is, so from main, you call basically run, right? And the logic that I used, and I used it actually for, I think, almost all the functions, is what I do is I create a struct that represents things that I need to remember, right? So that I need to have when I do this processing. And there is two things that I was keeping. Is one, at the moment, so this will change because endpoints don't exist. But for me, when you look at the network function, all the interfaces that we needed, I call them at the time endpoints. In the meantime, we have network attachment, we have interface, we have different names for it. But these are the things that I kept. I also kept existing NADs because what you see, and this is one thing that you have to bear in mind, is that these functions always run. So every time that that something changes into the package, these functions will execute. So one of the issues that we ran into, I remember when I was on the plane, is that John was running the NADs, but there was no content yet, so the function crashed. And I didn't test it with that because I didn't know. But so we have to build protections of these type of things in it because they get executed in various conditions, whether the data is there or not. So you have to protect the code, or you have to build the code in a robust way that you can deal with those type of things. Okay. So, but what I did,
they need to be, right? They need to be idempotent. I mean, they need to be able to be executed over and over and over and over again without the results changing. So that's
correct,
critical.
Yeah.
And
yeah, so yeah, also very good point. Yeah, so yeah, we have to, so they have to be robust and they have to do always the same thing basically, and the result should always be the same. Yeah, so that's important. So I basically create a struct, which in this case I initialize because it's a map, and I did not do a lock on them, but I think they don't execute in concurrent mode, so I did not do that. But so that's something, yeah, I never saw an issue with it. But because they execute in a single Go routine, in a single execution engine, unless you, of course, build a Go routine inside, then you actually have to protect that map with a lock, right?
Yeah, it's a single pipeline, so it's not multi-thread.
Yeah. So then what I always do is I always start by gathering information, right? So what you typically see in these functions is I build up the concept, what you get, and then you execute something, right? So that's kind of a little bit the logic that I always build inside of my functions that I write is I try to collect the data that I get represented. Because in our functions, so for example, there is two that we wrote, and we can go to the other example as well. You see lots of similarities. One of us basically creating NADs based on information, based on IP addresses that were there and based on the endpoints. And the second one was filling up the IP addresses, the blank IPs in a UPF deployment that were not yet filled in and would be filled in based on the IP addresses that got assigned. Because the flow that we have was NF injector basically builds or expands the UPF deployment with all the parameters that are needed, but does not yet fill out the IP addresses and VLANs. Then in sequence, but it also allocates all the IP allocations that need to be fulfilled. Then typically IPAM gets active and allocates the IPs. A VLAN injector will get active and they will probably run in parallel and inject the VLANs. And then these functions come into play and they take the IP addresses that were allocated, the VLANs that are allocated, and then we create an NAD from there. And then the second function was basically creating the IPs and the VLANs and expanding the blanks that were not yet filled in when we did the NF injector. So these are the things that what has to happen. So in other words, what I did, or that was the approach that I found, that I followed, is I tried to gather the information of the resources that would help me in basically, in this case, create the NEDs, right? So, and what do I need for them is, yeah. So what you see is that so based on that YAML representation, the resource list, you have all the metadata fields that are in the KRM resources, like the API version, the kind, the labels, annotations. You have direct access to it, so you don't have to do this weird, this JSON structure. You don't have to follow the spec to be able to get access to it. You have them, you can have, so there is a set of methods there that allow you to get access to those resources immediately, right? So for example, what you see here is that I walked through the whole list of all the resources. And what did I do is I initialized, so I got the UPF deployment. I needed the name because that name I actually use, I think I use it when I create the NAD resource name. I use that name just to say it belongs to that that UPF, right? Because the workload cluster needs to know that. Then I look at the IP allocation, and what I'm getting out of it, I'm trying to get the prefix and the gateway. So these are two things that we need into it, as well as the namespace. Then yeah, Sandeep, you have a question?
Yes, actually, I was following the code today. So at the same point, right? This IP allocation. So to start with, it is not in the package, right? The base package of UPF. It has only UPF deployment, cluster context, config map. These IP
Correct.
allocation resources. So at what point are they getting created?
So they get created during the NF injector. So there is two controllers at the moment that are acting upon them. So the NF injector that we discussed yesterday, I believe, creates the IP allocation, but they are empty. So in other words, they are a request to allocate an IP. So that comes in the NF injector stage. And then, and it also sets the condition to false. So the NF injector creates the IP allocation KRM resources, but the status is not yet filled in. And the condition, and it also sets the condition to false, such that someone needs to act upon it. Then the IPAM injector gets scheduled. One gets scheduled and sees that the IP addresses are not yet filled in. It actually fills out the status. It tries to get an IP address and fills them into the status of that KRM resource that was in the package. And yeah, so these are the two things. And then this guy will take that status field. So you see the prefix and the gateway, and he's using it in this context.
And recall that these functions get run every time you save that package. So when the IPAM injector writes that IP address into the status of the resource in the package, that's a save to the package. So these functions will get called as part of that save. So the save takes those new resources, executes all the function pipeline on that set of resources. So the first time when the IPAM request is created by the NF injector, the function runs and it says, there's not enough information here for me to do anything, so I just won't do anything. Then the IPAM piece comes in and writes in the IP address, and the function gets run again, and now it's saying, aha, I have enough information, I'm going to go ahead.
Okay. Okay, so the controllers basically mutate the base package. They create resources.
Yeah.
And what is the trigger? I mean, as the resources are created, these functions get called, and then they keep basically filling the values.
Yeah.
Right. I mean, that is the sequence, right, at a high level.
Correct, yeah. So NF injector creates
Yeah,
the IP allocation, and then it's the IP injector allocates the IP, and then this guy uses the information to fill out the NADs, and then there's another function that uses these IPs to fill out the blanks in the UPF deployment. I think we have time. We can go through that one as well if we have time.
Yeah.
Okay.
The point here, right, is the decouplings. The IPAM injector doesn't need to know how these IP addresses it's allocated are going to be used. This function comes along and takes that information from all they need to know is the IPAM injector needs to know I write it to the status, and then the function needs to know I read from the status and I put it in the right place. And so Wim mentioned earlier, we could make these functions have a configuration that comes in. That's exactly where it would come into play. The function config could say, take the status or the IP from the status of this resource, identified by name or label or something, and write it to these fields over here. So that's one way we could make this completely reusable across packages without having to write Go code for an individual package.
Okay. So yeah, I mean, I just want to repeat so that I understand. So basically, controller's job is more intelligent. It talks to other systems and it allocates resources like IP addresses or for some other, IP address. And then these KPT functions they just act upon the KRMs, and they basically set, replace, or add YAMLs to the KRMs based on what the controller has allocated. So
yeah,
KPT's, these functions job is like limited in scope.
So this in this one, for example, generates an NAD, right? So here we actually are, although if you looked at the CAP documentation, they basically say they are mainly for mutating and validating. Actually, this function generates an NAD.
Yeah. Okay. Yeah. Now it will help. Thank you.
Yeah. And just to be clear, sorry, if you just to sort of make so controllers have the added the reason controllers do the reach out to other systems and things like that is that the controllers they're long-running processes that can have write status and read status. They can retry and reconcile, whereas these functions are just running in a pipeline with a set of inputs, a set of outputs. They don't even necessarily have network access, volume mounts, or anything. They're very limited in their reach.
Yes, got it.
Yeah. And we have to decide which is in the function and which is in the controller. My personal view is the following. First, try to do a function, but as John said, if you have to reach out to the outside world, it's a controller, right? So that's already table stakes. But you can do a lot with functions, by the way. So, okay. But so the way I wrote or the philosophy behind those functions, and I haven't looked at the code for a while, but it's always I gather information and then sometimes I have to process it, so I have to manipulate it. But in this case, I didn't have to do it. And now what I'm doing is I'm just generating NADs for every endpoint that I collected. And I'm using the information that I collected and I put into that struct. So this struct basically holds me the various information. And now what I'm doing is I'm going to all the endpoints that I have. And for example, you see that I use the name of the UPF deployment and I augment it with the endpoint name. So that's what finally is the name that gets put into the NAD. And then these are the information that I put in the NAD file. And as you saw, I am, I think, I'm not sure where I'm doing it. So, so get NAD node is actually the template that gets executed based on this information that I put in. So like CNI version, okay, I think at the moment it's hard-coded. CNI type I got from the cluster context. So basically what I'm doing is I'm getting information from various places. and then putting it all together in the NAD, which is basically what is the end result of when I collected all the information. What you also see is that if you have errors, right? So let's say if there is errors during the processing, so we have standard in and standard out, right? So we have standard error as well. Now, not for all the errors you're going to create standard error. So what we also do is if you look at the resource list, it has a results field in which you can collect information on the execution pipeline. So what sometimes happens, so if you want to basically represent the error back towards the port system, so you can do that using this method. So you can basically add the results that are in the resource list that port defined, and you can augment errors or append errors. And then you see, based on the pipeline execution, you see all the errors that you have found or that you have run into during the execution. And that's how you could basically represent them back, and port will then make them visible into the system. Here, what happens is we are appending items to that resource list. So as we were saying in the beginning, so we have a flat resource list that we start from. So it's a flat list of KRM resources. And here I'm generating new NADs. To add them to the list is just, so we basically, the context is the following. What you see is that as we were saying, every time you save the package, you basically get these functions run. So what you sometimes ended up seeing is that, okay, we had them already in place, so we just override them. Otherwise, you see that every time the function runs, you get more and more NADs, and they are all the same, but so they are just added to the list. So you have to build in some protections for it, but it's not very complicated, to be honest. And that's it. That's basically the function. So it's very simple. If any questions here? I can maybe quickly look at the other one that we built during the POC, which is the injector. No, there's the controller. So that's the controller. There is. I think that's the one. Yeah. So here you see the way the structure of the code is the same, right? So I always, or at least that's my philosophy at the moment, I try to have the same, I think here probably I need to get rid of it, but there is a main, it's always the same. I run a transformer, of course, the current one here. And then the data is the same. It's a set of, here it was a bit simpler. I know this is actually a different one. Yeah, I started to explore with something that I could do with it, but you see, I always have the same logic: gather information, generate things, right? So here, so what you see is I was looking. I think this is an experiment. I don't think this is part of the POC, but you see always the same pattern coming back. Is what I'm trying to get to. Is I gather information based on what I need to do. And then what I am doing is I am filling out that information. No, actually, this is the right one. Filling the information based on information that I gathered, and then I fill out the resources, and then I override. If it does not exist, I override the resource, because that's how you basically get the new context, or I append if it does not exist. So, but the logic is always the same. Any questions on that? And so it's also easy to test, by the way. So for example, yeah, go ahead.
So if I want to run it and try it out without running the package deployment controller, I mean in my dev environment, is there, I saw the README, but I mean, so
here,
how do I?
It's just what I'm executing here. So you see here, so what I always do is, or personally I do, so in the data folder, and maybe we can have different data folders for different use cases. For example, to test all these corner cases and stuff like that, right? So what I did is, so one way to test your function without actually running them in a real controller, you see it here. So you basically source the data. So what this actually is, it represents that data in a resource list. So this kept function source data is basically looking all the content in that directory. I represent it in a resource list to this function. So it helps you to do that packaging. So we use kept, so that kept function to help us do that. And then you basically pipe it, which basically means you do standard in towards this code. And I even didn't compile it. So I just do go run main. So this actually executes all of the code without running it anywhere. So this basically, and it mutates. So anything that you were doing, do you see here? And the output is represented as a flat list, as in the same way as Porch would see that information coming back. So you see here that it's that data is getting filled out and stuff like that. So this is how you could basically test your code and see whether all the fields are properly manipulated and stuff like that, and you can do stuff like that.
Okay.
Yeah.
Okay.
And so you can also run this in a Docker container. So I always, as I was saying in the beginning, I think, yeah. So I start always doing it like this, right? So just go run main.go. And then I start, and then from the moment I'm happy with the results, I did some corner case testing and stuff like that. I start building a Docker container, but you can even run that locally. So this, if you run this, you would even run this locally in the same environment, but you run it as a container image, right?
Yeah. Okay.
Okay. I see Akash.
Yeah. Hi, Akash. Yeah.
Akash,
Thanks,
yeah.
Vim. So I have I joined a little late, so maybe if so sorry if the question is already asked or if it's already explained in a previous call. So the question is like when we are running the package controller, this kept function is going to work on the resource list. But on a package controller, when package controller is going to execute this, because there is kept file and there is pipelines, we mentioned that these are the functions, function list which is going to be executed as a pipeline. How does that get executed? Just trying to understand the flow. Yeah.
So okay, so this is Porch executes that, right? So basically what happens is that when you save a package, right? So Porch is basically executing the pipeline, right? What actually happens when the pipeline gets executed is it goes in a sequence. I think it does first validation and then mutates, but so there is an order. So, but it goes sequentially through that list, okay? Now, how are those functions executed in a Kubernetes system? And actually, I believe I built recently my system, so I'm not sure whether there is. Let me see.
Well, just I think you might be getting into more detail than the question is. So remember, Porch is an API. And part of that API is to create or update, that is save, a list of resources associated with a package or a package itself and the associated list of resources. Every time you do that, part of the process of that save operation is to execute the function pipeline of it's represented in the kept package, in the kept file. So if that fails, actually, I believe the save operation fails. So whatever gets stored is always a consistent and passing set of passing the pipeline. So you don't have to ever execute this pipeline yourself. You can execute it yourself. So Porch is sort of kept as a service. So kept is the CLI. You could go in and you can pull down the package with kept, package get, and then you can do kept function eval that's running the pipeline. And then, you can a kept package push or something like that. So like All of those things are possible, just dealing with kept CLI directly to Git. Porch puts a layer on top of that. It's a Kubernetes API that does the same type of thing. And one of the things it does is every time you save to that Kubernetes API, which is what our controllers all do, then Porch under the hood will execute the function list. And then, yeah, how exactly that's done is, I think, what Wim was about to get into.
Yes. Is that answering your question, or do you want to go to the next?
So just one small additional to what I mean. The thought I'm just saying is that you now Porch is kept as a service and it is executing those pipeline. But my question is, at different stages, different functions need to be executed. Like if there is IP allocation CR present, only then this particular function makes sense to be executed. So how does individual function know that does it get executed every time, like idempotently, and it has to check that this particular file is present or not, or resource is present or not, only then go ahead and execute, or that it can assume that it will be present, and the orchestrator will take care of it because it knows that there will be this file will be present. I mean, this IP allocation in this case will be present. That's my question, actually, more like.
Yeah, so at the moment you have to build in, so you always get scheduled based on when a package gets saved. So that means there is no guarantee that that resource is fully filled out or is even present. So we have to build protections in, when we build the functions, we have to build them in such a way that we can deal with those conditions. So in other words, those functions will run with everything okay or not okay or half okay, but we should build them in such a way that they are robust and that they are built in an idempotent way to get always to the same result based on the input that we have.
Thank you.
Yeah, exactly. Now that said, there are other ideas and concepts we're discussing, but right now, the way it works is there's one function pipeline, it's in the kept file, and it's idempotent. Now you can run functions, what we call imperatively. So if outside of Porch, if you were using kept, or frankly, a different, well, anyway, if you're using kept, you pull the package down, you can run whatever functions you want, and then you can save it back, and those don't have to be added to the function pipeline. So that's something we could simulate in a automation system, that same behavior. And that's part of what we'll talk about tomorrow in the package variant discussion for the package management thing, is some potential ideas around that. But the typical and current use of functions is exactly what Wim just said, that they live in the kept file. It's an ordered series, and I think it's mutators then validators, because you want to validate the final result. I think, but that's the current way it works.
Thank you.
Okay, so that probably moves us to the end, but I think it was a good session, good question. So I believe, probably going to another topic, it doesn't make sense. But if you look to the current page that we set up, it doesn't make sense to have a meeting tomorrow. And the topic, or one of the topics that we could go into, is IPAM, because we haven't skipped that, and there's a few things that we have to discuss on that side. Is that okay for all the people? Or
tomorrow what time?
8, same time as today, because otherwise we will overlap. I think John scheduled at 9. So the problem is there's many meetings tomorrow. So 8 would be another specialization workshop. Then I think 9, John scheduled the first meeting for the package management subgroup. And then we have TSC after that. And then after that, Tal is going to do a kept/Porch hands-on session. So that is lots. That is a lot tomorrow. But it would be 8 o'clock.
I'm okay. I mean, 8 o'clock works for me.
Yeah.
8 o'clock yeah.
If you could push that into the calendar, Vim, somehow.
I will do because I missed it. I need to ask John. I didn't find a way to do it properly.
Okay.
I put it into the list, but
No, it just helps because then everything shows up at least. Yeah. It makes it makes it easier to do all the time zone calculations and or Outlook can do it for me.
Understood. Yeah. Sorry about that. Yeah. All right. Thanks all. And then if there is no further questions, then we'll call it a meeting. Thanks and see you tomorrow.
And thanks very much, Vim, for all the great info.
Yeah, thank you, Wim. Thank you all.
Bye.